Hi all. Let's start with the PCIe physical layer. Uh, till now, what we discuss in the PCIe transaction layer and specifications and data link layer and its specification. Now we are moving to next layer of PCIe will be the physical layer. This is the last layer of PCIe protocol. So as I told previous PCIe having layer protocol. In that layer protocol we have a in hardware perspective we have a three layers: transaction layer, data link layer, and file layer. So in transaction layer, just quick overview of transaction layer will be it's whatever data coming instructions coming from the top layers will based on that it will generate the packets. Let us scenario where let us I want to send the I have a RC transmitter, I have a EP receiver. I have to send the packets. Let us assume 10 packets I want to send from transmitter to receiver. So transaction layer it will generate the packets. Based on that packets, data link layer will add the sequence number and LCRC. So from the top layer you will get the data, then after transaction layer, it will add the header and ECRC. Header will give the clear information, right? Where we want to send the packet. Let us in EP is the endpoint. Maybe any hard disk or any printer, any electronic devices is connected. So every device will have a own ID. So based on that ID, it will that information endpoint information everything it will mention in the header. So header will give a clear idea like where we want to send the packet properly from your transmitter to receiving end. So this is a header indicates data payload. ECRC will protect this packet while any throughout the from your transmitter to receiver any changes will happen, it will detect that error. That error will be reported through advanced error reporting mechanism. So in a transaction layer, whatever data coming from the top layers, you will get a this will add as a header and ECRC. Data link layer, it will add as a sequence number and LCRC. LCRC means link level, CRC errors. If any errors coming from the link level, it will detect using this LCRC. And sequence number means let us I want to send as a 10 packet. So every packet we need to give as a identity, right? That will be the sequence number will add as a data link layer. So whatever this packet we called as a total packet we called as a link packet. This we called as a link packet. Now this packet we are sending to file layer. Till now what we discussed up to this packet, now we are sending this packet to file layer. So what happen that file layer it will do. So in a file layer what happen, it will add as a framing token start and end. So it's start and end is a field it's helpful to identify the receiver side when packet is started, when packet is will end. So the clear idea to receiver like when packet is started, next we will get as a sequence number, next we will get as a header, next we will get as a data, then we will see as a ECRC, then we will see as a LCRC, then we will see as a end. So this field, everything it's very clear to receiver will understand. If you add a framing bound, this kind of boundaries, these are the for every packet we are adding a boundaries so that receiver will understand like when packet is started, when packet is ending. So in this way, physical layer is a one step will be the boundaries will add. Um, let's discuss in a physical layer is a one point will be the adding framing tokens. That is a one point. One more will be the in physical layer we have a mainly two parts. One will be the logical subblock and electrical subblock. The logical subblock will be the take care of digital design engineer, design engineers. So this will take care. For electrical injuries, this electrical subblock will be the it's kind of sender team, SEDAS team. So that this will take care on electrical subblock. It's kind of electrically we have to manually we will see the whether it is working fine or not. But this is the simulation level. This we will the manually we will see the whether it is that electrical subblock working fine or not, we need to see. So in electrical subblock we have a analog parameters like analog blocks like PLL for generation of clock clock recovery, clock domain tracing, clock recovery purpose, clock recovery circuits, some serial to the parallel to data conversion, parallel to serial data conversion, A to D converters. So all the blocks is present in a electrical subblock. For digital blocks for simulation level, we see logical subblock. In the logical subblock itself, this is the framing tokens, everything will be there. One more point will be the in a physical layer we have a main challenging will be the link training. So you want to send the data from your transmitter to receiver, but it should be link should be present, then only you can able to send the data, right? So this link is we called as a link training happen in the physical layer that we call as a LTSSM, link training and state machine. So this link training happen through based on specifications. Link training will be trained like how many lanes we are using. Let us say example, I want to use as a 16 lanes. This PCI controller, I want to use as a 8 lanes. I want to use as a 4 lanes. Based on specifications, link training will happen. That we call as a LTSSM step. So in a physical layer, we have a this is a major challenging role. Now we'll see the main in this VLS engine will more focus on the logical subblock. So logical subblock will have a this is a block which make the physical layer. The logical subblock will be the referred to transmitter unit and receiver unit is also present. So in a logical subblock and electrical you have a two, right? Where it is mentioned. Let's take it. In a logical subblock and in a file layer we have a logical subblock and electrical subblock. In logical subblock also we have a transmitter, we have a receiver. In electrical subblock also separately we have a receiver, here also transmitter is present. So it will be the connection happen through some interfaces we called as a custom interfaces. In middle also we have a connection will be there from transmitter to receiver, one layer to another layer. It's connected through some internally interface will be there. This interface we called as a custom interfaces. So in a logical subblock we mainly focus on the blocks will be the data scrambling, 8-bit NB encoding, and packet framing. Packet framing I already discussed. That packet framing help you to identify the receiver side when packet is started, when packet is ended. One more will be the 8-bit NB encoding. 8-bit NB encoding helpful to say get the proper information from your you are sending from transmitter to receiver data. You should get the proper information from receiver transmitter to receiver side, so then only we can say that that packet is correct. So by using encoding schemes it's helpful for you to send the packet properly. One more point is will be the to doing encoding here is will be the like to recover the clock, like let us take scenario where you are sending 8 bit NB encoding. So 8 bits means let us assume 1111, 10 bits you are sending from your transmitter to receiver, let us assume 5 ones 5 zeros. If it is like this, so what happen, the crack recovery will be the it's very difficult to recover the crack from the data. So we are in a PCI we are not able, we are not sending clocks up through this data. This is a main advantage. So what happen, whenever you are recovering data, whenever recovering clock from the data, so what happen, you have a number of clock toggles, like you have a number of one sign zero, so like that 10 10 10 10 10. So what happened, these are the changes 190 10 10. What happened, clock also recovery become very simple through that data. So this is a one advantage. So using this encoding block, one more is the data scrambling. Data scrambling means it's kind of we have a lanes with very shorter distance, right, from your transmitter lane and receiver lane. So what happen by using scrambling, what happen, you can eliminate the inter-symbol interference, some clock domain, crosstalk. It's what happen due to crosstalk, what happen, you won't see the proper data from your transmitter to receiver. Sometimes what happen, you won't get a proper data. So in order to overcome these problems, we'll see using as a data scrambling. So these are the main parameters we are using from transmitter perspective in logical slug block. So these are the point I want to cover in this. And one more will be the 8-bit encoding. We'll see separate video on that, how 8-bit encoding will happen. So we'll see Gen 1, Gen 2, as I discussed in a previous recording, previous video. 8-bit NEB encoding will be there from Gen 1 and Gen 2. From Gen 3 onwards, we are using 128 by 130 encoding scheme.